right, ladies and gentlemen, our final review and getting ready for the big upcoming growth, decay, and logarithm unit test. Some things in here will take some good time for. Other things we're kind of just going to go, oh yeah, we remember that, and kind of roll with it. So stick with me here. State whether the functions represent growth or decay. Now, typically, growth again happens when our b value, the value we're taking to the exponent of x, is greater than 1. And if it's between, oopsie, let's try that again, there we go. And if it's between 0 and 1, it's going to be decay. So for the most part, I can go through here and go, growth, 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 decay. Be careful. Okay, I'm giving you a hint here. When you're looking on your exam, watch. If there's a negative x on one of these, that causes whatever's underneath to go in an inverse. So let's say this would have been negative. Okay, that would cause this to act as though it were 1 over 2, which would be decay. So be on the lookout. Just trying to be a good helper. Okay, for the next group, state the y-intercept, shift, domain, and range for each function. Okay, so as we're looking at these, first thing I notice is there's no funky shifts going on. So my y-intercept, remember, occurs when x equals 0. Okay, so if I take anything to the 0 power, is 1 times 2 would be 0, 2. Can I get that a different way, though? Sure can. If I wanted to, but again, I don't want to have to go to my calculator for everything I do. So understanding that when there's no shifts, you know, that y-intercept is just going to be my a value is a good thing. But let's say I forget. Okay, that happens. Pull up my chart, go to where x equals 0. Okay, but it's a coordinate, and it needs to stay that way. Shifts, don't have any this time. And when we're graphing with growth and decay, remember, my domain is infinite. It's going forever to the left and right, and that will never change on these. My range, though, will always be from 0 to infinity unless, okay, that'll always be 0 unless there is an up or a down shift. If there is, it moves with it. And we'll see that in one of the upcoming examples. When I get to 6, okay, y-intercept. Now before you write 0, 2 again, that's considering there's no shift. We said that on the first one. Well, this time there is one. So we're going to take a quick peek here and see if we can make this work a little easier. Okay. So here, I get my y-intercept straight to the calculator. I just go to where x equals 0. Okay, let's keep it simple. My shift, when it's in an exponent, is left or right. Okay, it's the opposite of what I would think. So this one's going to be right 1. Okay. The domain, still the same. Okay. And if I look at the picture of it, I notice even though it's growth, it still hugs where? It still hugs the x-axis. It still hugs 0 to infinity. Why? Because my shift isn't up or down. Okay. Only when it's up or down on growth and decay will that be the case. Now when I get to my last one, oh, now it may become clear to me. At least I hope it will if it hasn't already. So I type my last one in. Biggest thing I can get myself into trouble on this last one, making sure my -3 isn't up in the exponent, because that'll get me a different answer. So here, y-intercept. Steal it from my chart. Steal it from a coordinate where x equals 0. Okay, my shifts this time, left or right, plus is going to be left 2. So again, up in the exponent, minus is right, plus is left. And then this is going to be down 3. And that's going to be important to me. Because when I go to graph it, I already know on growth and decay, that's negative infinity to infinity. But when I look at the graph on this one, I notice something. It's not hugging the x-axis anymore. What happened? It moved down 1, 2, 3, and now it's hugging that line. So down 3 connects with my range. Okay, if I'd had an upshift here, it would have moved up, and that would have been a positive number. Those are the types of connections that we're looking for. Okay, graph the functions, name any transformations, do your domain and range and end behavior. Okay? So here, all right, graph the function. Easiest way a lot of times. And we'll notice we just keep moving. We're not getting cute. We're not, sitting around forever. Anything like that. I'm going to plot a few points that I pick up from my chart. If you're doing this on your own at home, again, just kind of remind yourself. Phone apps, lots of them that work well with these as well. But here's what I want to notice as I'm graphing. Notice what number my y's are getting really close to. 2. Well, why is that? Because this plus 2 stands for a shift of up 2. My whole graph moved up from hugging 0 to hugging 2. So when I graph it, my graph should reflect that and not go through that point. We talked about our domain and range, and we'll try to keep that on the screen as we're looking at these. Might not be easiest, though, but we'll try. Okay, our domain, we don't have to think about. Our range. We mentioned if there's any up or down shifts, like there was here, that moves my range. So my range was moved. And then my end behavior, you're like, oh yeah, the f of x and x stuff and blah, blah, blah. Remember, we're making connections with these. Domain is my x values. So these go here. And the order's not going to be as important on my x's as it is on my range values, which are going right here. So for those of you that have talked to me, here's how we've tackled this. And no, it's not time to go. I look at these and I go, okay, so here, as x approaches negative infinity, as x goes to the left, so as I go to the left, is my y value getting closer to y equals 2 or y equals infinity? Well, what am I doing? I'm going up forever. Well, if I'm going up forever, that's towards infinity. Y goes up as x goes left. I'm going left, I'm going up. Makes sense. So my second one then, if that's true, as x goes to positive infinity, as x goes to the right, what's happening to my y value? Well, it's leveling off. What's it leveling off near? 2. Y gets closer to 2 as x goes to the right. Okay? That's how we do that. We make the connections with domain in x and range in my f of x, which is a fancy way of saying y. But when I get to the next one, oh, I threw the twist in. You're like, wait, we haven't done these with ln. Natural log and log work the same way. So my first thing I look at is, I look at the shift. Inside the parentheses is my left, right. So this is a shift of right 3. Okay? When we're doing logs, left and right makes a change to my graph because normally it's at 0. So I move my asymptote right 3. And then you have your choice of plotting your parent points at 1, 0, and 10, 1, and then just shifting them right. We'll take a peek at that here in a second. Or you can just go to y equals, type in your values, punch up your chart. Okay, there's my asymptote, the last error message. And if I plot these 2 points, 4, 0, holy moly. The other one I went so far I can't even get it on the screen. Okay. So we get that graphed and we just remind ourselves, even though it looks like my graph stops there, we know better. We know it doesn't. We know it just hugs the asymptote. And I can get that on. Now, if you wanted to use your points, again, 1, 0, and 10, 1. I'd plot those, and then I'd move right, 1, 2, 3. I'd move right, 1, 2, 3. Okay, so both are going to work. You just got to pick one. With these, though, and I want to make sure I get the last one in here again. Okay, this time, my range goes down and up forever. So it swaps from when I was doing it with growth and decay. Okay. My domain, my x's are what are moving. Because that right 3 moves my domain right 3. So you start to notice, oh, so with growth and decay, it's up and down, it's my range, because y is up and down. And here it's my left and right shift, because x moves left and right. And hopefully you start to see those things, because that's also going to be how I do my end behavior. So this time, my range is the one that's infinite, so I can just write it right away. But my domain is the one over here, and this is the one where I got to think. So as y goes down, because negative for y is down, I'm getting closer to leveling off. I'm getting closer to my 3. Okay? As x gets closer to 3, y goes down. Yes, it does. But then as y goes up, I'm going out and out forever. Connections. Got to make them, and the more you practice them, the easier it is to make the connection. 11, when looking at the function f of x equals 100 to the 5 negative x, Deanne thinks it must be growth since the base is greater than 1, which is true. Is she correct? No. Why? Because 5, or 5 over 1 to the negative x, you can use the word reciprocal here, you can use the word flip, or you could even do it as simple as showing me the flip and then explaining that 1/5 would be decay. You can't just say it's a negative exponent, because depending on what's inside, that's not going to always be decay just because it's a negative exponent. But again, we've seen that a few times, and we're going to roll with that some. 12, if f of x is 5 to the x and g of x is 5 to the x minus 4 plus 1, explain how to obtain g of x from f of x. What are the transformations? What are the shifts? Left, right, opposite of what I think, up in the exponent. So right 4. Plus 1 is my up or down. In this case, that would be up. Now the next part, I either need to know my logarithmic pieces here, like 5 and log of 5 are inverses, or my change of base, log of 27 divided by log of 1/3, log of big divided by log of little. And that's going to be the true for the rest of them, 17, 18, and 19. I'm not going to do all of them, A, because now that you have an example, you definitely can, and you've got a key to work with, too. Rewrite the following in the logarithmic or exponential form. Okay, I want to turn this into this, and I want to turn this into that. Now, to me, it's usually easier to do the log ones first, so I'm going to do this one first. That's my base. That's my exponent. That's my answer. Okay, and I'm not solving it, I just leave it. So then I come over here and I start comparing. I'm going, okay, now what's log? Okay, this is my base, so base, okay. And then this is my exponent. Okay, so that went with that. So my exponent was the equals side. And then the answer was what was right next to log. All right, so let's see here. You're like, Harty, you messed that up. It's base, exponent, answer. Base, exponent, answer. This should be base, exponent, answer. 5 to the 4th equals x. 2 to the x equals 16. So see, I even got to take my time with this and make sure I get it right. Okay, expanding and condensing. At this point, you should have so many notes on your worksheets, I shouldn't even have to talk to you about this. But again, I've got the note off on the sideboard if you need it, so I'm not going to write it here. So here, I look first when I'm expanding. Do I see any quotients? Nope. Don't see any divide. Do I see any products? I do. 3 times x. So where that little multiplication dot would be is where my plus is going to go. I don't have any exponents, so I don't have any power, so I'm done. 23. Again, natural log works the same way as log. Do I see any division? I do. That's going to become subtraction. I get to divide, subtract, make a new log. Do I see multiplication? I do. Between the 10 and the x. So there, natural log of 10, the times becomes plus. Natural log of x minus natural log of 3. Any exponents? Nope. Done. And then the last one, we're going to get the best of all worlds. Here, do I see division? I do. Now, when I see division, again, that's the only part I want to do here at the start. Okay, nothing else. Now, if you can do multiple steps at a time yourself, that's fine. But I'm just not going to go that route. Okay? Product. 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 So this is going to be a lot. Log the x to the negative third plus log y to the fourth. The minus is still there. Log 4. Multiplication becomes plus log y. And then finally, if I have exponents, they're going to turn back into coefficients. So some of these can get to be really, really long. But I get set. We get to 25, condense, everything goes opposite. Okay? Power, do I have coefficients? If I do, those go back into being exponents. Product, nope, because natural log's a label, so I don't have any of those. And then I look, I see a minus, that's my quotient. So quotient means x to the 7th, there's my divide, y. Condense, single logarithm. And again, I just keep continuing with those steps. Coefficient becomes exponent. Plus is my product, so plus becomes multiply. 5 times y to the 1/2. And I don't see any minus. That one's done. And similar to what we had up above, we're going to hit everything in this last one. So I have coefficients. So those go back to the top. I have a product. Okay, so I'm going to get these two put into a single logarithm. Again, where the plus becomes times. And then finally, I have a minus for my quotient, which is going to become divide. So we're going to put these final two together. My product will be up top because it's written first. Minus is my divide. And I put my 8 in. Okay, so that covers everything. But again, we've had so many sheets and assignments with this that if you still need more practice, you probably just need to finish some of those up. Okay, find the inverse. Switch x and y. And here's the biggie I remember from the last quiz we had with this. Solve for y. Well, to solve for y, I need to get rid of log 4. Can't divide by it. Oh, yeah, it's that big word again. Yep. We're going to exponentiate. But again, remember what it means. Exponentiate means it's becoming an exponent. Don't write 4 times x. That's not the same thing as 4 to the x power. So we've got to get that in there, and we'll be A-OK. You're like, Harty, you are moving. Well, there's a lot of stuff to get through here, so we got to do it. Okay, solve the equation, reminders. Log of x and its of value are inverses. E and natural log are inverses. We've written that about a bajillion times. So here, 5 to the x power can't divide by 5. Got to use a log. I didn't mean to cross out the x there. Now again, when I get to this point, I can't type this in the calculator and it looks like that. It doesn't work. We're going to use change of base, log of big divided by log of little. And here, if they don't tell us any better, we'll just go to a couple of decimal places. We won't go crazy like we have been before doing some of those. Well, what if it's the log I'm trying to get out of the way? Same idea. Going to exponentiate. Going to use that log base as my exponentiation. And again, this is 5 to the 4th power. 5 times 4, big difference, as you can see. And get my answer. Natural log. I use E. Now again, E on the calculator. It's been a while for some of you. Is second in natural log, right next to the 4. Do my rounding there. And divide by 8. Decimals are A-OK in this section. Now, this last one is the one that people are like, oh gosh, but we saw this on a couple of assignments. Here, I wish I could just use log 4, but I can't because both of these have variables and they're different bases. This is the one where I have to have these two being the same base. So can I take 4 to some power and get 16? You're like, yeah, 2. Okay. So we're going to change 16 into 4 squared. Because now, since the bases are the same, since the bases are both 4, I can use the log of that base to take care of the 4. It doesn't zap out the 2, though. Okay, the 2 is still there, along with the 2x minus 3. But now it's algebra 1. So the one place I have to think is, how do I get them to be the same base without changing the value? Because 4 squared is still 16. It's not like I changed that. Make sure we distribute the 2 all the way through. Minus that 4x out. And divide by negative 3. Not too terrible, not too terrible, not too terrible. When we're doing logs, if I don't see a base, so I know it's 10. But before I can use 10 to exponentiate, the log has to be isolated. And I've got a value out here. Now that I've kind of exposed the log by getting the 2 out of there, I can exponentiate. And we'll see what 10 to the 1.5 is. I don't think that off the top of my head is a good idea. Yeah. And then add my 44. So I can get funky decimals. Okay, don't think you're doing it wrong just because you get a funky decimal. And again, on a few of these, you should have looked at them already. This shouldn't be hard. You've got to pause or slow down because no, you're supposed to be checking things, not just being a copycat. Here, I got logs of the same base, 1 per side, so I'm fine. Use my 5s. Zap them. And we're to Algebra 1 already. So as you can see, a lot of these are going to go quick, but you have to have had the practice long enough to be used to it, so you just know, oh, the inverse of log is to use its base. Oh, the inverse of ln is e. Oh, the inverse of log is to exponentiate. If you've practiced, you'll get there. Here, same thing. Minus the 1 first. Okay, can I use e yet? No. Natural log of x hasn't been exposed. Now it is. And now I can exponentiate and e to the 2.5, just to let you know, 12.18. Set there. And believe it or not, we're coming down the home stretch here. And like I said before, the test itself is not going to be this long. I'm going to cut and paste and nab a few things. For the applications, I'm still going to give you this. Okay. Population of a city in 1985 was 1,275,390. The population was growing at a percent of 4% per decade. 4%. Growing. Okay, little clues. Now, be careful. Per decade, I underline this for a reason. Okay, a decade is a 10-year period. We started in 1985 and went to 2005, so normally I would think my t is going to be 20 because it's 20 years later, right? But it's per decade, every 10 years. How many 10-year periods are there between 85 and 2005? 20 divided by 10 is 2. So I can put this in on the y equals part, but since I'm not really looking for a bunch of values, I'm just looking for 1, I could just type this in on my regular calculator and work it that way. Now, I will say one thing, and no, I'm not going to mark it wrong on your quiz if you did it, but it's kind of a gross thing to think about. Okay, we're talking about people here. Don't write 0.82. You don't want to have 0.82 of a person. That's gross. So let's get that set. And 37, the same way. Value of a new car purchased for $18,500 decreases by 8%. If you're not sure how to get it as a decimal, divide it by 100. What's the value of the car after 4 years? Now this time, I'll do it the other way, just to let you see. Now, if I'm going to do it in the y equals part, I'm going to use x as my exponent instead of 4. Because if I use 4, I'm going to get the same value all the way down. If I do it this way and I look at my chart, and I go to 4, so 13,253. Okay, how many years until the car is worth 10,000? Again, keep scrolling down until that y value goes under 10. And the answer is somewhere in the middle. Or if you wanted to write 1 year, you just write the 8, because that's the year that it would actually make it down. Okay, 38. You deposit your paycheck in an account that pays 3.5% annual interest compounding continuously. How long until the balance triples? They didn't tell me. I get to create my P, whatever I want it to be. I'll make it 1,000, because I'm boring like that. E we know is a value. Here, be careful. That 3.5 is not what I'm using as my percentage. I still got to divide that by 100. So 0.035 T or X, whatever you want to use. How long until it triples? Whatever number I use here, 3 times as much, goes on this side. My y equals. Type in just the right side. Second ln, again for my e. And I'm going to look at my chart, and I'm looking to see when Y goes over 3,000. Now, this is going to take a while because that's not much of an interest rate. Almost there. Holy moly. Whew. 31 to 32 years. You better find you a new account. Make that easier. The growth of a stock's value after its purchase in 1985 can be represented by the equation. What was the value of the stock in 1985? That's my base year. That's when t equals 0. So what happens when you take something to the 0 power? You get 1. So this is really $500 times 1. 500. What's the annual rate of growth? That's just the percentage, and it's not 0.04. We want the actual percent, which would be 0.04, the opposite of what we've been doing up above. Here we've gone to percent to decimal, we divide by 100. Now we're going decimal to percent, we multiply. And then just a couple more interest, and we're going to be off and running. Suppose we invest $8,500 in an account paying 4.5% interest compounded monthly. Find the account balance after 10 years. All right. There's my starting value. 1 plus. Divide this by 100. 0.045. Compounded monthly. How many times does monthly happen in a year? 12. Find the account balance after 10 years. Okay, again, I can put that in y equals if I want to, but I don't need to because I'm only looking for one value. I just have to make sure I type it in right. Now this time we're talking about dollars and cents. So if we get decimally this time, there's nothing wrong with that because, well, we do partial dollars. 41. How many years will it take for an account to double its value if it collects 5% interest compounded quarterly? Use the formula from number 40. Okay, didn't tell me how much. 1 plus my rate. Quarterly, there's 4 quarters in a year. And I just noticed something I did boneheaded. If somebody hasn't said anything, we're going to go back to 40 here in a minute. I see what I did, and I can't believe I did it, but life happens. 4 times how many years? I don't know. And how long will it take for it to double? So here's one again, where I'm going to have a variable in my exponent. Yes, we still are going to go back to 40 here in a minute. Bonehead Harty here. Sure my values are typed in right. We're looking good. Now this time I'm way past here. Okay, where's that first 2,000 come up? There it is. So 13 to 14 years. But let's rewind for a minute. Hopefully somebody said something to me back on 40. I'm really hoping so. Because I got going so quick on 40, I did something boneheaded. Let's check this out. Principal, 1 plus rate over n. Harty, you just put t. You didn't put n times t. So this should be 12 times 10. That's going to get me definitively a different value. Let's see how much money I had cost myself initially by not paying attention to what I was doing. Woo! I need to get fired for that. 13, 3, 19, 44. Yeah. Cost a customer $5,000. Let's see how long I stay employed there doing that. Whew. So yeah, got to watch out for those things. But see, it lets you see. If you get rolling along, you got to kind of watch out a little bit. All right. 42. We got money in 2 different accounts. The first account contains $3,000 and accrues 3.8% interest. It's modeled by this function, so there's one equation. Second account contains $2,600 and compounds 5% interest daily. Right here. how many years will it take for them to have the same balance? Okay. So here, I'm going to type each of these in. Make sure I actually typed them in correctly. Okay. So I pull my charts. Now I notice if I start back at 0, okay, first one's bigger than the second one. So now I'm going to look and see how long is it going to take for the second one to become bigger than the first one. So it looks like it's going to take somewhere between 11 and 12 years. Because here, column 1's bigger than column 2, but then in the next one, it's the other way around. So it's going to be between there somewhere. Which account is a better long-term investment? Now me, I would say B. B. After 12 years, it makes more each year. Now again, if it didn't say long-term, you could say, hey, A, because I'm only going to keep my money in there 10 years or something like that. But you've got to have some logic and reasoning behind it. Again, you can't just do cause this was 60,000 at the start. No, that doesn't tell me. Or this was 3,000 at the start. Again, we're looking at an investment. We're looking longer term. One last story problem. Kind of running down the same format as 42 did here. We've got to decide between two job offers. We got Busy Bee Industries, base salary of $60,000 plus an $1,800 annual raise. There it is. Bugsy Corporation, base salary of $50,000 and 8% annual raise. Right there. Because that's the 1 plus 0.08. That's why it looks a little different than we do it sometimes, like we do with these, but it's the same idea. So, which offer is best? Again, don't just look at the initial salary and go, oh, Busy Bee. Busy Bee. No. We have got to type these in individually. Don't lose your X on your 1800. That could be a problem. Stick too many zeros on one of these other ones. All right. So, when we go to check these out side by side. Now, yes, at the start, Busy Bee making a lot more money. But I noticed the question that's down here at the bottom. How many years later will the salary from Bugsy, column 2, exceed the salary from Busy Bee, column 1? So I start to look. It doesn't take long. By the time I hit year 4, column 2 is bigger than column 1. So, with that in mind, okay, so here's my first year. So it doesn't take that long, and all of a sudden, Bugsy is more. So, which offer is best? The only way you could probably tell me that Busy Bee is better is if you're only going to take a job for a year or two. But if, after 4 years, Bugsy makes more for rest of career, rest of life. We've talked before about how people's average work lives are about 40 years once they get into the workforce. If it only takes me 4 years and I'm going to make more money for the last 36 years of my life, I think it makes a lot of sense. I think that job offer is going to be better long term, even though I'm making $10,000 less at the very beginning. Something to consider. Homestretch, people, last page. 44 we crossed out because we didn't talk enough about the E to start talking about growth and decay with E. We're not going to play that game. What is the asymptote of the graph of 4 to the x minus 2? Now, remember, this is a growth and decay problem. I can even look at it if I need to. I shouldn't really need to, but if that makes me feel more comfortable, I could. So 4 to the x minus 2. So I look, okay, it's growth. Remember, the asymptote is, where's the magic line? What's the value that y is getting closer and closer to but not quite getting there. Okay? You're like, a -2, it's really close, but it's not getting there. Look at my graph. Where's it leveling off? Near -2. How could I know that without graphing it? What's the shift? Down 2. Okay? When I'm doing growth and decay, what affects my asymptote moving from 0? Up and down shifts. Down. If it would have been up, I'd have done this one. Okay? That's what I'm looking for. Which of the following is equivalent? I need to expand this. So again, remember, when we're doing expansion and when we're doing condensing, again, in case you're not in class to look at the sideboard. So when I'm looking at my expansion, now again, you will not have all this stuff in red to be looking at when we're going through a test, okay? That part you need to remember. But as you think about this, okay, I go, okay, expanding, see a quotient. So when I see a quotient, that means I hit a subtraction where that divide comes, and then I get another log going with it. Then I go to product. I've got those on each of these. So this is going to get kind of big here. Now, before I get going too far, because I'd get there and I'd start doing this, and I'm like, log 2 plus log 4x minus log 4. That's multiply 3 plus log 4y. And I start to panic because I look down at my answers and I go, there's nothing that's that long. Okay? This did not say which one is completely simplified. It says which is equivalent. So let's back up a step. Do I see anything after I've done my first step that's the same? Well, that's divide. That's not it. Log 4 2x minus log 4 3y. Oh, okay. So after you do each step, check, because if the answer's there already, go ahead and use it. Okay, don't make it worse than it needs to be. And then finally, what's the value of -3 times 2 to the x when x equals 0? Two options. What's anything to the 0 power equal? 1. -3 times 1 is -3. Otherwise, could I punch it in the calculator? You know it. Okay? So, here's the deal. The test itself will not be as long as this review is. So you don't freak out. Okay? Your test is not this long. It's approximately 2/3 of this size. You know, you'll have to do the math on that part. But we're looking mainly at, again, if you see 3 problems in a section, you're probably going to see 2 that are that way. 4, you'll see 2 or 3. But you've got to sit down and be ready for this. This is not going to be one of those tests that I'm going to sit and let you go, oh, I only made it to number 15. I'll be in for the next 4 days to take. No. You're going to sit down. You're going to get done with what you get done with in a class period. If you don't prep, you're going to bomb. And then we do the retake process if we need to. It goes back to what we talked about in class about being professional, being prepared, and then looking at me as your boss saying, okay, you know, here's this presentation that you've got. Are you ready? If not, great. Your grade will be an A. Your pay will be an A or a good grade or passing, whatever it is for you. If you don't prepare, I can't fire you, but I can say, okay, here's the grade that reflects that. So be ready, get set, check it out, grab an extra if you need. Good luck.